Welcome to Django Model, a popular object-relational mapping or ORM library for Python. After watching this video, you will be able to explain the core concepts of Django ORM and convert your entity relationship diagrams into Django models. Recall that ORM can make the developer's life easier by abstracting databases and automatically mapping objects and methods to tables and SQL queries. Now you will learn how Django ORM, a Python ORM component that belongs to the Django Web Application Framework, can help speed up your application development with databases. In Django ORM, each Django model maps to a database table. When you create a class object, it represents a table row. Each field represents a table column. Schema and tables are automatically generated once model classes are defined. For example, you can define a user class, which is a subclass of the Django model. Django will then create a corresponding user table in the database by generating table create statements and creating columns based on the class fields. In our example, a first name column will be created based on the first name field. Each field in the model should be defined as a field class. Django maps each field to a column type. Here, first name is defined as a character field and will be transferred into varchar, and date of birth is a date field and will be transferred into date. For each column, we define its metadata, such as type and constraints, by specifying parameters in a Django field class. For example, for the first name field, we use the max length parameter to specify the length for varchar. Once we have defined models and fields, Django ORM will generate schema and table create statements. First name, last name, and date of birth fields are converted into columns. Each field has customization parameters such as null, blank, default, or primary key. Next, we model the relationships between entities. Django ORM supports common relationships such as one-to-one, many-to-one, and many-to-many. We will start with a one-to-one relationship. Suppose we have an instructor and user ER diagram. User class holds some common fields, such as name or date of birth, and instructor class has some special fields like is full or total number of learners the instructor has. One instructor can only have basic information stored in one user class, and one user can only have one role, such as instructor or learner. Now let's convert the ER diagram into two Django models. First, we define the models, instructor and user, and their fields. To define the relationship, we define an extra one-to-one field to act as a foreign key pointing to user. Django ORM will create instructor and user tables with a foreign key in the instructor table pointing to the user table. We'll use a project and course ER diagram to illustrate a many-to-one relationship. The project class represents a course project with fields such as project name and grade. The course class represents an online course entity. It has atom fields such as name and description. More importantly, it has a collective field called projects, which represents a set of course project objects. Thus, one course would have many course projects, and one course project would only belong to one course. This is a typical many-to-one relationship. To create models in Django, we add an extra course field as a foreign key. Note that this is not a one-to-one field because multiple projects may have the same course field. For a many-to-many relationship, let's look at a course and learner ER diagram. One course may have many learners enrolled, and one learner may enroll in many courses. To model this relationship, we add a many-to-many field to one of the models. Normally, the many-to-many field should go in the model which will be edited most often. For instance, course will likely be edited on an hourly basis as learners are added or removed, but each learner may only enroll in a new course on a weekly or monthly basis. Sometimes you need extra information about the relationship between the models. For example, you may want information about the enrollment that occurred between learners and courses, such as the date enrolled. Django allows you to specify the model that will be used to govern the many-to-many relationship. In our case, the intermediate model is the enrollment table. It is associated with the many-to-many field using the through argument. Model inheritance in Django is like inheritance in Python. You need to determine if the parents are just holders of common information that will only be visible through the child models, or if parents should have their own tables. There are 3 scenarios for model inheritance. Use multi-table mode when you're subclassing an existing model and want each model to have its own database table. Use abstract base classes if the parent class will just hold information. Use proxy models to model the Python-level behavior of a model without changing fields. Multi-table inheritance is like a one-to-one relationship. The only difference is you need to subclass instructor from the model. Django will create a new instructor table and a one-to-one field in the instructor class. As such, inheritance for multi-table classes is an implicit one-to-one relationship. We have defined entities and relationships for our online course database. Now Django will create these database tables and foreign keys automatically. User table is the base table which has ID as the primary key and contains atom columns such as name. Learner table is inherited from user and has a many-to-many relationship with course through an intermediate enrollment table. Instructor and course also have a many-to-many relationship. Lastly, the project and course tables have a many-to-one relationship. Now that Django has created these tables, we can perform read, update, and delete operations on the data. In this video, you learned that in Django ORM, each Django model maps to a database table. Each field maps to a column type, such as int, varchar, or date. Each field has customization parameters. And Django ORM supports common relationship patterns such as one-to-one, many-to-one, and many-to-many.